Alright, this is Ubaid on behalf of Electronics, and in this video we'll continue to solve word problems. Okay, starting 59. Okay, so when a certain professor was hired in 2005, the enrollment at a college was 8,500 students. So we know that this is your base. 5 years later, in 2010, the enrollment grew to 11,200. Okay, determine a linear growth function that models the student population in years since 2005. Use the model to predict the year in which enrollment will exceed 13,000 students. Okay, so remember, okay, your base is 8,500. Okay, so 8,500 students. This is your base. Okay. All right, so base. Okay, this is what you start off with. This is 8,500. Now, in order for you to find the coefficient of your variable x, okay, you will need to divide the growth by 5 years. So we know that 5x equals 11,200. Okay, take away 8,500. Okay, so 5x. Okay, in 5 years, the growth was 11,200. Take away 8,500 students. Okay, which basically means that x equals 11,200 minus 8,500. It's a total of 2,700 divided by 5. Okay, so 2,700 divided by 5. This will be 540. So 540 students altogether. All right, so 540x. So y, which is basically your total number, okay, of students, okay, y equals 13,000 students. Okay, they want the year. Okay, so y equals 13,000 students. Okay, and our equation will be y equals 540x. Okay, this is an increase in the number of students plus your base, which is 8,500. This is what you started off with. All right, so we know that y equals 13,000. We'll sub in 13,000 for y. Okay, and we'll need to isolate x to figure out the value of x. Okay, so we know that 13,000 minus 8,500 divided by 540 will give you x. All right, so we can do our math on the calculator to reduce errors and omissions. So take away 8,500, okay, divide by 540. So that's a total of 8.33. Okay, so x is roughly 8 years. Okay, so x is 8.33. Okay, or approximately 8 years. So we know that the enrollment started, okay, in 2005. Okay, which means 8 years from 2005. Okay, this will be plus 2005. Okay, it will be 2013. Okay, so your x equals 2013. Okay, so by 2013, your enrollment, okay, will be 13,000 students. Now you can sub in, okay, this value over here, 8 years for x, to figure out for y, okay, to verify the solution. So we know that y equals 540 into 8 years, okay, plus 8,500. Even type in 8.33 to be exact. So 540, okay, well, we'll need to round it off later anyways. Okay, so 540 into 8 plus 8,500 gives you 12,820 students. Okay, and if you had used 8.33, you would have arrived to a solution closer to 13,000 students. This is approximately 13,000 students for verification purposes. Okay, so this is basically how you figure out the total number of students. Now, apart from that, okay, let's go ahead further down and look at 61. A classic car is purchased for 24,500 and is expected to increase in value each year by 672. Okay, so what's the purchase price? 24,500 over here. So purchase price is 24,500. So this is one of your antique cars. If you're buying cars for investment, if you think that this car will go up in value, which most of the classic cars do, and that's the reason why they're sold off at auctions, okay, you will need to know at what rate, okay, this value will climb up each year. All right, so we know that 24,500 is the value of the car right now, okay? It's expected to go up each year by 672, okay? So the increase, sort of like your acceleration in speed, is $672. Okay, this is also helpful to know for insurance purposes. If you need to insure your classic car, your vintage car, your antique car, your muscle car, whatever that might be, your classic automobile, okay, from 1920s or 1930s, okay, this is the best way to figure out how much insurance you would need to insure this car based on the increasing value. Okay, so 24,500, and whether or not you can afford to store these kind of vehicles in your garage or somewhere else. Okay, so 24,500, okay, increases $672 every year. Okay, now they need a linear function that models the appreciation. Okay, notice the word over here. This is not depreciation. Appreciation is the rise in value, okay, increase in value of the car in terms of the number of years after purchase. So if you don't drive the car, if it's going to sit at one place, okay, apart from the rust, okay, the car may climb up in value. Why? Because this car is rare. Okay, any equipment, any personal property that is rare, okay, such as your jewelry, okay, anytime something is rare, it goes up in value, okay, because as time passes by, you can't find this kind of material anymore. As time passes by, you cannot find this car anymore. Okay, nobody manufactures this car. Maybe it has been discontinued. Okay, maybe the manufacturer shut down. Okay, nevertheless, the car, okay, was fantastic. Okay, so for that reason, if you want to figure out the linear function that models the appreciation of the car in terms of number of years after purchase, okay, what we can do is we can use this value over here, $24,500, okay, plus, okay, this value, 672, to write an equation, okay? So we know that the retail price is 24,500. This will be your base. So we know that Y equals 24,500. This is what you start off with in terms of the value of the vehicle. And then you gradually, okay, increase the price of the vehicle, okay, as you store it for more than a year. Okay, so 672x. X stands for number of years. So we know that Y equals 24,500, and we need to figure out what the value of the car will be after 7 years. So this is 672, that's the increase in price into 7 years. Okay, so Y equals 672 into 7. plus 24,500. Okay, this will be a total of 29,204. Okay, we can do that one more time. So 672 times 7 plus 24,500. Okay, this will be 29,204. $29,204. All right, so this is basically how you figure out the final price of the retail price of a vehicle that you expect to appreciate in value. Now, based on this retail price, along with the make and model of the vehicle and the storage conditions, okay, the rating of the vehicle itself, so on and so forth, you can figure out what your premiums are going to be. Okay, 7 years later, if you do need to store this car, if you do decide to keep this car, okay, either for storage or if you plan to resell this car, okay, sometime later. Okay, so this is basically how you use linear equations to solve word problems. On behalf of V Electronics, this is Obey. Have yourself a great day.